Now, let's look at a couple of compressor failures to see if we can determine what caused them to fail. Here's one right here that is one of the super heavy duty ones, and obviously somebody sent this in, and if we look at it in the front, we'll notice that this one that's new, the clutch front plate is nice and clean. This one's burnt up. So right away, visually, I'll look at this and say, we have a compressor that's in the process of seizing up. Let's see if our thermal fuse did the right job. I can't even begin to turn that, where this is easily turned. So we know right from the beginning that this is seized up. So what I'm going to do is I'm going to take a digital volt ohm meter and I'm going to put it on continuity test to see if our clutch fuse did its job properly. I should be able to touch the 2 pins that are inside here and note that the circuit is open, so I shouldn't hear any beep sound. And that's what we're seeing. So the fuse did the job. This compressor seized up, most likely from lack of oil, but the driver is able to make it back and make his delivery without losing the belt. Let's look at a different style compressor. This is a York upright, or a TCCI. First thing we'll note on this is, here's one that has a clutch already on it. They can come with the clutch, or the clutch can be bought separately. There are several different sizes of clutches for this style compressor. These Sandin style most always come with the clutch already installed on them. But on this one, we'll notice it has this ugly looking ring on here that's all full of oil. This is actually a felt wick, and it's purposefully on this compressor. Its job is to keep any oil from getting on these 2 plates. Again, this clutch works just like this one. As you put current to it, the magnet pulls them together. You got steel on steel, friction causes the compressor to turn. If I get any kind of oil between those 2 plates, it's going to slip and it's going to cause my clutch to fail. So that's why this wick is here. Remember I told you our vehicle slowly loses a little bit of refrigerant? This is one of the points. The seal will weep a little bit of refrigerant and oil out, and that's again what this collar is supposed to catch. But in the case of this one, we had a catastrophic oil failure, so in other words our seal went out on us, and most likely on this one, yep, it's locked up and the bearing's out on it. What happens often is, because this one is assembled without the clutch, often technicians will put the bolt in here with an impact wrench, and in the process of running that down quickly, they can actually fracture the seal or damage the bearing when they pull that through. You may be wondering about that system not losing refrigerant. Think of your home. You've got a refrigerator, maybe a freezer, you've got an air conditioner at your house. How come you don't have to go out and recharge that every couple of years? What's the difference between those systems? It's functioning exactly the same as this. Think of your home air conditioner. You got a condenser sitting outside, the air handler or the evaporator is either sitting in the attic, or it's in a garage, or it's in a crawl space, something like that. What connects those two? We have solid, soldered copper lines. We have what they refer to as a hermetically sealed system. In other words, your home air conditioner could probably run 15 years and never lose an ounce of refrigerant or oil. Your refrigerator, I've got a refrigerator at home that's 30 years old, sitting out in the garage, still running like a champ. Again, it's all copper soldered together connections. Unfortunately, because this is mobile, we have to have flexible hoses. We have to have a belt driving the compressor, so we have a crankshaft seal. So we have places where we're going to have leaks. So that explains where we lose our refrigerant. Here's another situation on a vehicle. This is a compressor that looks brand new. If you look at the pulley, it doesn't even look like the belt's been running on it for more than a couple minutes. But right away, I notice, here's what a normal plug looks like. Remember earlier on our diagnostic, we said look at the plug and the wires. Here's one where somebody has literally cut the ground wire off of the plug and grounded it himself. I'm looking at this saying, he must have an electrical problem somewhere, and he didn't know what to look for, so he just decided, I'm going to make sure it's grounded. So Let's do a real quick continuity test on this one to see if this coil is still good. It could be a situation where it was a bad coil and he was just double checking it, but let's do a double quick check. We should, if the coil's good, be able to hear continuity, the little beeping noise. Can we hear that? This compressor is still good. Unfortunately, he's got an electrical problem somewhere else, but he turned it back in. Here's one where we can hear the bearing has gone out on it. The hub is seizing up on it. Again, we could take any of these that are locked up, take this 17 mm plug out, turn it upside down and check for oil. A minimum for these type of compressors should be 6 ounces of oil all the time. Full, it's 10 ounces. Remember, 10 ounces is just shy of a full soda can, so it gives you a perspective of how much oil is in this. When I turn this upside down and nothing but a shot glass of oil comes out, it is not the compressor's fault that it locked up. It's just like you took your oil pan plug out of your engine and then took off and ran your car. The engine's going to lock up quickly because of lack of oil.